Hello, once again, you are welcome to our network basic training. If you're joining this channel for the first time, we are running a training on basic network administration and management. And our attention is focusing on absolute beginners into the networking field or network administrators who are trying to understand the concept of networking, or people who are in the advanced level who want to understand certain concepts. So whichever category you are, you're welcome. We're looking at Module 5, Communication Principles. And this is a core aspect of understanding network. There are a few aspects that you need to understand when it comes to network generally, okay? This topic is one of them, and you need to understand it. We're going to take it as slow as possible, as make it as simple as possible, okay? If you have not watched Module 1 to 4, I advise you to go back to the channel and then watch Module 1 to 4 so that you can comprehend what we are going to be talking today. So we will be focusing on communication principles. During this course, we are going to be looking at the concept of communication protocols, and we'll be describing network communication protocols. We'll be looking at communication standards and describe network communication standards. And we will also explain the concept of network communication model. You will be hearing about what we call the OSI model and the TCP IP model. These are core areas when it comes to explanation of communication over the network. So let's delve into it. What is a protocol actually? A protocol is simply rules, okay? Rules that are laid down to govern a particular procedure. That is it. So when we say communication protocol, we are basically talking about the rules that have been laid down to enable communication. You know, communication has to do with a sender and a receiver. So if I am talking to you, for instance, I cannot say my communication is complete if you do not comprehend and give the appropriate feedback to the message that I'm giving. So communication in our daily lives takes many forms and actually occur in various environments. We have different expectations depending on whether we chat via the internet or actually participate in a job interview. Each situation has its corresponding expected behaviors and styles. So before beginning to communicate with each other, we have to establish these rules, or rather, we have to establish this agreement that will govern our conversation. And this will include the method of communication that we will use, because it's between sender and receiver. So we have to establish that. We have to also agree on the language we're going to use to talk. Okay, so I cannot speak in English and you don't understand English, probably you prefer French, and then you think that we are talking on the same frequency. So we need to understand the language. And do we need to confirm that our messages are received? The answer is absolutely yes. So now let's look at these two people in this image that are trying to establish their own method. All right. Or they can say we can use sign language to communicate. All right. Or they will say we can write notes. And then she says, sorry, I do not understand what you are saying. Yeah. And then he say, can we use written notes? And then he says, yes, note would be free. In other words, we are trying to understand. One person does not understand sign language, the other understands sign language. Or one person knows how to write, the other one does not know. So there needs to be some form of agreement. So in communication, You know, that the sender have to actually initiate. For instance, in understanding or establishing the role, this young man is asking the lady, can I speak Japanese and English? Or he says, I can speak Japanese and English. He's giving her the options. And the lady says, I can speak Spanish and English. So you see, they will have to now find a common ground. And then the young man says, we can communicate in English then. So you see, they have established a language of communication. Then it says again, I would like to order 3 black shirts, all right, size medium. Okay, he is trying to make an order. And then she says, yes, I understand your order. 3 medium black shirts. And he says, yes, that's correct. Thank you. Now, observe in this communication, first of all, there is a rule that was set, and the rule is the language of communication. And they all agreed that they will use English. After that, they now said, okay, he now places his own request. And then he's placing the request based on the language that is agreed. And then after she has received the message, she had to ask for verification. And then he now confirms what she is saying. So you see, in communication, you need an appropriate feedback to whatever it is you are saying so that the receiver will understand. So these rules or protocols must be followed for the message to be successfully delivered and understood. Among the protocols that govern successful human communications include an identified sender and receiver. There must be a sender and receiver. An agreed upon a method of communication, either face-to-face, telephone, letter, or photograph. Okay, there must be a method. Then the common language and grammar to use in the communication, whether you're using your native language or you're using a foreign language, whatever it is. And then the speed and timing of delivery. Then finally, confirmation, acknowledgement requirement. How do I know that you actually understood everything that I have said? Those are things that needs to be put in place. So the techniques used in network communications share these fundamentals with human conversations. So think about the commonly accepted protocols for sending text message to your friends. Okay, I'm sending text message. Different people like to have their own format of sending the message based on the content. They need to have an agreement. So why does these protocols matter? Why does these rules matter? Just like humans, computers use rules or protocols to communicate. Protocols are required for computers to communicate correctly across the network. In both a wired and wireless environment, a network is defined as an area where all hosts must speak the same language, which is the computer terms. All right? Means by they will have to share this protocol. So if everyone in the same room spoke a different language, they will not be able to communicate. Likewise, if devices in a local network did not use the same protocol, they will not be able to communicate. So networking protocols define many aspects of communication over the network, okay? Now, there are characteristics that we need to actually look at when it comes to protocol, all right? Because the protocol we said are actually the rules that have been set, you know, to govern this particular communication. So let's look at some of these protocols and characteristics, okay? Now, the message format. A sent message uses a specific format or structure. It depends on the message type and the channel used to deliver the message. The message size. The rules that govern the size of a piece communicated across the network are straightened. They are different depending on the channel that is used. So a long message sent from one host to another over a network is necessary to break the message into smaller pieces, ensuring that the message is delivered reliably. Okay, it's like, should I say, eating bread. if I pick a big bread, or I pick a big bread and I want to eat this bread, it is bigger than my mouth. If this is a bread, it's bigger than my mouth. And for me to consume it, I need to break it into chunks, into different segments, into smaller pieces. Then I will now pick each of these pieces and I'll eat. So the message size depends on the rule that has been set. The rule says that the size of the message is dependent on the size of the channel, the medium that is going to be sent. So the size of my mouth is different from the size of another person's mouth. So those are the things that we're considering. Timing. Many network communications functions are dependent on it. Timing determines the speed at which the bits are transmitted across the network. It also affects when an individual host sends data and the total amount of data in any transmission. And then encoding. Messages sent across the network are converted into bits by sending host. Now, each bit is encoded into a pattern of sounds, light, waves, or electrical impulses, depending on the network media over which the bits are transmitted. The destination host receives and decodes the signal to interpret the message. What are we talking about here? That if you listen to the previous class, we said what forms a network. You have an end devices, and then you have an intermediary device, then you have a network medium that connects. The network medium could be cable, wire, electrical cable, where the data is sent into electrical signals, or optical cable, which is sent through pulses of light, or a wireless medium, which is sent through electromagnetic waves. Whichever medium it is, the lowest bit that, the lowest format that the computer will actually understand is binary. We said it in our first class. Binary is like the mother tongue of the computer. It's like the language of the computer because it's just a combination of 0 and 1. Okay? So, if this encoding aspect is saying that there is a rule that covers how these binary zeros and ones are converted to be sent through this network medium. If you are using copper medium, all right, which means you're using maybe Cat5, Cat6 cables, the data would be converted into electrical pulses. And this encoding tells you how that conversion takes place. If you're using fiber optic, the data in binary will be converted into pulses of light. This encoding explains how that will happen. And if you are using wireless to communicate, it will be converted into electromagnetic waves. The encoding explains how that is taking place. Okay, so that is also another characteristics that will be looked at. Then you have what they call the encapsulation. Each message transmitted on a network includes a header that contains the addressing information that identifies the source and destination host. Otherwise, it cannot be delivered. Encapsulation, in adding to this information to the data that makes up the message. In addition to the addressing, there may be other information in the header that ensures the message is delivered correctly. When we're talking about encapsulation, if I have this data here, and this data, it's a letter, I want to send it across, so I have to put it inside an envelope. Putting it inside that envelope is called encapsulating. So I have an envelope. So this data, this letter goes into this envelope. It is encapsulated. Now, this envelope will be addressed. I will put the name of the sender and this and this and this and this and this. So I have addressed my message. The envelope is just the, how do I put it? The container that the message is inside. The real message is inside the envelope. The envelope is the container and has the addressing. I now take it to maybe a courier service, maybe UPS or DHL. And DHL takes this and then envelopes it in their bag. In a particular bag, they pick this letter and envelopes it into their mail bag. All right. And then they readdress it. Are we together? So the message is inside the envelope is inside that mail bag, and in each case, it is readdressed, it is encapsulated. Are we together? Then that particular bag is now taken to another box. That box contains all the messages that are going to a particular location. Are we together? So you see, this process is called the encapsulation. The encapsulation is just the process of adding header information. Header information are just information meant for the destination. So by the time it gets to a destination, the first one is removed, and then the next one is removed, the next one is removed. And so that process of removing it is called a decapsulation until it gets to the receiver, who will now open up the envelope and then remove the data, which is the letter in itself. So that is the concept of the encapsulation. Then the message pattern. So messages require an acknowledgement before the following message can be sent. This request-response pattern is a common aspect of many networking protocols. However, other types of messages are streamed across the network without concern about whether they reach their destination or not. And that is why there is a pattern in which it's sent. If you send a message, there should be an acknowledgement and things like that. So those are some of the things. So now let's look at the communication standard. With the increasing number of new devices and technologies coming online, how is it possible to manage all the changes and still reliably deliver services such as email? How possible? The answer is the internet standard. Standards are, benchmarks or, rules or benchmarks that have been set to govern this communication. So a standard is a set of rules determining how something must be done. Okay, so you see the concept of rules comes into play again. Networking and internet standard ensure that all devices connecting to the network implement same set of rules or protocol in the same manner. Very important. Why are we saying so? It's like saying every student that is admitted into a university, the rule or the standard is he should be given a matriculation number. That is a rule. And that matriculation number is what that person will be identified with. Okay, so it's a rule. So different devices send information to each other over the internet using these standards. Now, let's look at all these organizations that form these standards or that manages these standards, or rather that ensure these standards are kept and are observed. So a comprehensive discussion, problem solving, and testing cycle results in internet standards. These different standards are developed, published, and maintained by various organizations. Okay, we have organizations like the IEEE, Internet Engineering, Internet Electronics Engineering, all right? Then there's the IETF, Internet Engineering Tax. All these are different bodies that governs. We have the IANA, all right? Internet Assigned Number Agency. Then you have the ICANN, all right? The Internet Corporation for Assigned Names and Numbers. We have the TIE, we have the ITU. We have different bodies globally. And these bodies are just a group of people like you and I that join this particular agency to say, okay, we want to contribute our own take. So we come into discussions, and at the end of the day, we come to an agreement. when we come to an agreement, because it is stakeholders that make these bodies come to an agreement, and then we begin to go to reinforcing. But when it comes to reinforcing, there is a particular document that we put that enforcement, and everybody will have to go and abide by it. So these different standards are developed, published, and maintained by various organizations. The proposed standards development and approval process are recorded in a number of RFC documents. When we say RFC, we're talking about reference for comment document. It's a document that is published and made publicly for people to be able to make comment. And this tracks the evolution of the standards. So RFC for internet standards are published and managed by this body, the Internet Engineering Task Force. Are we together? So we will be talking about these bodies one way or the other, we'll be talking about them, and we will see the roles that they play. Now, let's go to the communication models. When we are talking about communication models, it is these standard organizations that have come together and have looked at this concept of communication over the network, have looked at it, and then have said, this is the best way to explain and to express the concept of communication between two devices, between a source and a destination. This is what happens. So there are two models. One of the model is called the TCP IP model. TCP stands for Transmission Control Protocol. IP stands for Internet Protocol. All right? So this one has its own model. We're going to look at it. Then we're going to look at another reference model. So the TCP IP model says that layered models helps us visualize how the various protocols work together to enable network communications. Layered models depict protocol operations occurring within each layer and the interaction within the layers above and below it. The layered models have many benefits. It assists the protocol design because protocols that operate at a specific layer have defined information that they act upon and a limited interface to the layers above and below. It fosters competition because products from different vendors can work together. It enables technology changes and occurs at one level without affecting the other levels. And then it provides a common language to describe networking functions and capabilities. These are the benefits of this particular layered model. So the first layer model for network communications was created in the early 1970s and referred to as the Internet model. It defines 4 categories of functions that must occur for communication to be successful. And that is what we're saying. We're going to look at these 4 layers. That is what the TCP IP model is saying. That for communication to be successful between a sender and a receiver, the message must go through these 4 layers. What are the layers? The suite of TCP IP protocols used for internet communications follow the structure of the models as we have seen. Because of this, the internet model refers to this TCP IP model. And you have layer 1, layer 2, layer 3, and layer 4. These are the layers according to the TCP IP model. Like I said, this topic is a fundamental topic for you to understand generally the concept of networking. Okay, so let's move ahead. The network access layer controls the hardware devices and media that makes up the network. Remember, for you to have a network, you must have your end devices, between source and destination. Then you have your intermediary devices. Yeah? Then you have your network media. So you have a network. You have end-to-end devices, an intermediary device, then you have network media. Now, this network access layer is talking about the connection between the end device and the network media. Can you see? It's talking about any of the device and the network media. That's why it says it controls the hardware device and media that makes up the network. Includes your cabling, includes your network card, includes, everything that is related to that. Then the second layer is talking about the internet layer. This one determines the path through which the network will follow. And that is talking about the intermediary device here. The intermediary device, in most cases like the router. Okay, so the internet layer is saying that when the traffic comes here and gets to this intermediary device, how does the traffic know where to go? How does it know where to follow? That how to know where it goes or to follow is now the job of the intermediary device or the router, and is managed by this layer. After that, then you have the transport layer. The transport layer basically controls, how do I put it? The security of the data. Are we together? Partly. It also controls the size of the data. Remember, we said sometimes if you want to eat something and the amount is too big, you need to segment it, you need to break it. It is the job of this transport layer. It will segment this data into different segments and then pass it through the channel. So while passing it through the channel, it uses like port numbers in order, so to secure, how does it secure it between the sender and receiver? That's what handles them. Then you have the application layer. The application layer represents data to the user plus encoding and dialog control. This is where the message is generated at the end user, or the message is received at the destination. That's the concept. So you see, we will look at each of these layers in details as we go further. Now, this is the TCP. Now, there is another model called the OSI reference model. OSI means for Open System Interconnection. It is another model that explains the same concept of communication between a sender and a receiver. But this time around, it has some more details in it. It says that there are two basic types of model that we use to describe functions that occur for our network communication to be successful. The protocol model, which we just looked at as the TCP IP, and it closely matches the structure of a protocol suite. The protocol suite include a set of related protocols that typically provide all the functionality required for people to communicate with the network, the data network. The TCP IP protocol model is a protocol model because it describes the function at each layer of the protocol within the TCP IP suite. That is what we have looked at. Now, there is another one, which is what we are looking at now, the reference model. The reference model describes the function that must be completed at a particular layer, but needs to specify exactly how a function should be accomplished. This model does not intend to provide sufficient details to define precisely how each protocol should work together with each layer. The primary purpose of the reference model is to aid in a clearer understanding of the functions and processes for network communications. That is it. So like I said, It is to explain and make you understand between the sender and the receiver. What happens? All right. So the OSI project at the ISO created the most widely known internetwork reference model. It is used for data network design, operation, specification, and troubleshooting. This model refers to the OSI model. So you see, in the TCP IP, how many layers do we have? Right, we have 4 layers. In the reference model, OSI, how many layers do we have now? We have 7 models. So you see layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, layer 7. Now, we will come and see the relationship between the two. But layer 1, which is the physical layer, the physical layer protocols describe the mechanical, electrical function and procedural means to activate, maintain, and deactivate physical connection for a bit transmission to and from a network device. Are we together? So the physical layer is also part of the network layer of the TCP IP model. So we are saying you have your end device, which is source. You have your end device, which is destination. You have your intermediary device. You have your network medium. The physical layer, we said, describes what? Mechanical, electrical functions, and so on and so forth, which means it deals with what happens here. Deals with what happens there. Yeah? If you are using wireless, your phone must have a Wi-Fi. The Wi-Fi of your phone is the physical layer. If you are using laptop, you have a cable that connects to your laptop. That cable the network card and the cable is defined by the physical layer. But most importantly, your data will come and pass through the network medium. That network medium between your system or your end device and the network medium, the data is converted into a particular format. Remember, we talked about encoding. So that encoding is managed by the physical layer. Then you have the data link layer. The data link layer protocols describe method for exchanging data frames between devices over the network media. Now, at the physical layer, your data is called bits. At the data link layer, your data is called frame. And you see here, the device that basically functions at this layer is called a switch. Okay, that's what we call the layer 2 switch, or that functions because it describes the method for exchanging data. Now, you see the data link and the physical layer here, the two of them form exactly what the network access layer is. The two of them form the network access layer of the TCP IP. Then you have layer 3, the network layer. The network layer provides services to exchange individual data over the network between identified end devices. So the network layer here is like the internet layer of TCP IP. But what is the difference? Because this guy deals with what happens here at the intermediary device, the router. The device that works basically here is the router. Now, why did we call in the TCP IP is called internet layer? In the OSI model is called network layer. Why is it so? Internet simply means interconnection of networks, and it describes the connection of between different networks on the internet. But you see, when you say network generally, Here, it describes even the local connection, which is the intranet, which is your LAN connection. So it describes your LAN connection, your WAN connection, your WAN and MAN and things like that. It's all compassing. But basically what happens here, it deals with how your data is routed, how it moves around. And the device that functions is the router. And the data at this level is called packets. It's called packets. Yeah? At the data link is called frame. At the physical layer is called bits. Okay? Then you have the transport layer. Transport layer is very important, especially those of you that are interested in cybersecurity or network defense or network security and things like that. That happens basically between layer 3 and layer 4. Because layer 4, the transport layer defines services to do what? To segment, transfer, and reassemble data for individual communication. So you have your data like this. So the transport layer segments it. So when it's segmented, it's like you want to do Weibo from Lagos to Abuja. You want to do Weibo. So what did you do? The size is big. The car cannot carry. So they now segment the items and put in different cars, in 5 cars. So this portion is put in this car, another portion is put in another car, but all of the cars are going to where? They are going to Abuja, the same destination. So the transport layer manages that, all right? And then the protocol that works there is called the TCP and the UDP. And the data at this level is called segment. All right, it's called segment. Then you have what they call the session layer. The session layer, which is layer 5, the session layer provides services of presentation layer to organize its dialogue and manage data exchange. You know, it's like when you log into your email or you log into an online portal, and your login is successful. If you leave it open for a while and you leave it idle and you're doing some other thing, what do you think will happen? It will log you out. After like some minutes, it will log you out. Why will it log you out? It will tell you session timed out. That's the session layer. The moment you want to communicate, it's like saying, I pick my phone and I dial your number. As I'm dialing your number, the session is not yet open. No. And then the moment you pick my call, the session is open. Then we begin communication. And then we begin communication. Once we are done communicating, even if you didn't end the call, we are done. The system is just left idle. The best thing to do is to just off it, to close the session. So the session layer manages this kind of communication stuffs. And then you have the presentation layer. The presentation layer provides typical representation of data transferred between application layer and services. And in this particular case, it depends how the data, the format in which the data is presented, either compressed or is encoded or decrypted or, encrypted and things like that. In some cases, maybe if it is picture, what format? Is it JPEG? Is it GIF? Is it PNG? If it is movies, is it MP4? Is it MOV? If it is audio, is it MP3 or whatever? What are those formats? All is at the presentation layer. Then the application layer contains protocols used to process communication. This is where the services are generated. This is where the data is generated. You see, like DNS, DHCP, email services, all those things, they work at the application layer. So data is called, the PD is called data at these 3 layers. These 3 layers. So this is when we want to compare. Because TCP is a protocol suite used for internet communication, why do we then need to learn the OSI protocol model as well? The TCP/IP model visualizes the interaction of the various protocols that makes up the TCP/IP protocol suite. It does not describe general functions that are necessary for all networking communications. It describes the networking functions specific for those protocols in the TCP/IP protocol suite. The protocols that make up the TCP/IP protocol suite described in terms of the OSI reference model. So you see here, TCP/IP is made up of physical and data link model. All right. Network access is made up of physical and data link of the OSI. The internet is the network. The transport is transport. Then application layer of the TCP is equivalent to the session, presentation, and application. So the function that occurs at the internet layer in the TCP/IP model suite are contained in the network layer of the OSI model. All right. The transport layer functionality is the same between both models. So the key similarities are the transport and the network layers. However, the two models differ in how they relate to the layers above and below each layer. The OSI layer 3 of the network layer maps directly to the TCP/IP internet layer. This describes protocols that address the route message through the internet. So in both cases, the device that functions there is the router, whether it's the TCP/IP or the OSI. Data is called packet, whether it's the TCP/IP or the model. All right. The only difference, like I said, is that the internet layer of the TCP/IP is specific to internetwork traffic, but the network layer of the OSI generalizes all form of interconnection, whether intranet, internet, or extranet. Okay. The OSI layer 4 of the transport layer maps directly to the TCP/IP transport layer. This layer describes general services and functions that deliver ordered and reliable data between source and destination host. So the TCP/IP application layer includes several protocols that provide specific functionality to various end-user applications. Application software developers and vendors use the OSI model layers 5, 6, 7 as reference to produce applications that operate on networks. So the TCP/IP and OSI models commonly refer to protocols at various layers because the OSI model separates the data link layer from the physical layer, which commonly refers to this as lower layers. Okay. All right. So, in summary, what we have looked at is the fact that communication over the network is explained by the concept of the TCP/IP and the OSI. They are basically rules that governs this particular communication within these layers. And understanding this concept is very, very key. So this is where we'll draw the curtain for today's session. We look forward to chapter 6 very soon. If you have question, you can put it in the comment section. Feel free to subscribe so that you can get notification of the next lecture. Have a good day.